Always makes me think it's not going. But here we go. It's gonna be a super short set of notes. It's gonna be a boring video because then after this, I'm gonna make you fill out the parts and then show you the answers. Okay, polynomial. Do you remember this from last year? By the way, a dance is coming up, right? Isn't homecoming coming up? Right? Okay, so I got my math shirt tomorrow. And if you noticed, we got 2 Wednesdays and I wear a math shirt every Wednesday. It drives me nuts that this is in the way though, because it kind of ruins the writing on the shirt. But tomorrow will be a dance you can do at homecoming that deals with math functions. Everyone's doing it. It's cool. All right, so you got to remember this from last year. I did this with my students. There's only a smattering of people I had last year, but remember this is a positive x squared, a parabola, right? And then this is a negative x squared, right? Ends. And then last year we did x cubes. That's a positive x cubed. And then this is a negative x cubed with a negative leading coefficient. Then what happens with an x to the fourth? Positive, negative, x to the fifth, positive, negative. You want to get nuts now? X to the sixth, negative x to the sixth, x to the seventh, negative x to the seventh. You can just go crazy on the dance floor. Linear, okay, linear is just straight, but it still has these ends. And then that's a negative linear. All right, so on and so on and so forth. They don't seem impressed. Okay, anyway, what the heck is this thing? Every math book I've ever seen, this is how they describe a polynomial. And the kid's looking at this going, A's, N's, X's, N minus 1s, what is going on here? And all that's happening is they're just saying that this is the highest degree. So if this was x to the fourth, then x to the 4 minus 1, that would be x to the third. Then all the way down to x to the first, and then actually x to the 0. That's why this is called a sub 0, the coefficient. The coefficient in front of x sub 0, or x to the 0th power, is just 1. So that's the constant. This isn't really here. This is actually equal to 1. So I'm trying to get you to understand the math language. So what does a sub n represents? It just represents the leading coefficient. It'd be some number. That's just my bad writing. This pen's actually very good. I'm very excited. The degree of this function is n. It's the highest top dog degree of the polynomial. In this case, it's a letter. Right? And that's all it is. It's just letters to describe what a polynomial is. So, bless you. All right. Now, looking at this, real fast, this is the length of the notes. And after this, I'm going to have the video on and just show the answers as I have them do it. But this first one, what's the degree? Let's all say it together in 3, 2, 1, go. What's the degree? 8. So here we go. And is it positive or negative leading coefficients? Positive. So therefore, the leading coefficient is actually 7. So this would be this. You'd end up and up. Can't get my, wait, I'm missing the camera. There we go. You'd end up and up in that polynomial dance scenario. Ooh, what's the next one? Let's see if we can trick you. What's the degree? 3, 2, 1, go. Wrong. What's the degree? Actually, 1, because this reduces to 2x plus 1. So it is a polynomial. 6 over 3 is 2. You'd split this up into 2 separate fractions, and then 3x over 3x is 1. So the degree is 1. The leading coefficient is 2. They were getting tricky with you. Oh, that's linear. So just, go like that. I think this camera is reversed, though. Might get confused. Reverse imaging, I mean. Okay, what's the degree on this one? Half and half. 4th hour got this right. What's the degree? 3, 2, 1, go. Oh, I heard weird answers. I heard 2. What's it actually? 3. No, it's 5. If you foiled this out, this would be degree 5. How many said 5? Liars. I didn't hear that many people say it. Did you? Okay. All right. What's the leading coefficient? This will be interesting. 3, 2, 1, go. Now you're lucky. Well, it can't be 3, though. It's negative 3. Now I wish this was a 3 in here. I'm going to do it. All right. Now what would the leading coefficient be? Oh, this would be tough. Let's see how good you are. I got a beep boop, beep boop. It's kind of a big number. 3, 2, 1, go. What is it? Negative? I heard someone say 81. Because if I foiled 3x plus 2 3 times, you would get a leading coefficient of 27x to the third plus a bunch of stuff. And you got to be able to do this. You don't actually multiply it out, but to get the leading coefficient, you'd have to think about what would happen if I multiplied it out. which I'd have 3x times 3x times 3x, and then multiply by -3. So it'd be negative 81 x to the fifth if I did that. But I don't have that. This is me writing really bad. That's not my pen. I'm being a bum. All right. So, but anyway, that's not the case. So the leading coefficient is simple. It's -3. I gotta breathe more. Oh, okay. Now, over here are non-examples. There's a fat or max. This would actually be 5 over x squared plus 1. That's called, you don't know this. This is the one thing we didn't do last year. Coming up, though, that's called a rational function. G of x, we did do this last year. This is actually 3 times the square root of x plus 2. Do you remember that? 1 is the exponent. 2 is the index on the radical, which we never write. We never write 2 for square root. We had cube roots and fourth roots and all that last year. Then this last one, where are there more x's, top or bottom? It always makes me sad, robots that do the subtraction rule of exponents. You should just know that 2 of the x's cancel and there's 1 left over on the bottom. This is called a rational function as well. You did not do those last year. You know nothing about those yet. All right, we'll hit those. But we're just saying these are not polynomials. So be careful on that. Okay, now, like I said in the video, this is going to be boring because I can't pause it. But go ahead and do those first 3 questions, what you think is happening. Those graphs are pretty spot on. There are some things I'd like you to maybe note to self what's going on. So what are they doing? They're doing this. I'm just going to reveal the key, filling this out. Okay, you have this in the blank notes if you're home, not here. I did have 1 absence last hour, so. Okay, and then I'm just going to go right to the key on this one and show you what we got. I think one of the things is missing on the key. Let me get my piece of paper. Someone take 2. Maybe I took 1. I think I do have 1 of the notes, so good. No, see, that's a good note sheet over here. Get what's looking at it. Nope, I don't see it. I don't know. Well, it's like someone took 2 notes. Walk around real quick. Good. I just want to make sure my letters match. I don't think even I showed the key here. One is missing. For points of inflection, maybe just mark them where they're at in the graph. There's no values on the x-axis to give a location, like, or coordinates. So don't even guess. Just mark where the points of inflection are. Then, if you don't want to wait for everyone else, you can proceed on. But I'm giving everyone a chance to fill out their own first 3. Then you can check them, make sure you're on the right course. Last year, we definitely did cubics, and we definitely did, I'll tell you what we actually did. You probably did not graph 3 last year. You definitely did graph 1 and 2 last year. Remember synthetic division? Remember that? Okay, synthetic division is fun. I like it. It's a great math tool. But we didn't go as far. I mean, I mentioned, and I'll show you where we mentioned them. It's actually 4, 5, and 6. Boring video, boring. Nobody sits here? Nobody sits there? Who? Trader. Teller? Teller trader? T-shirt. Sit in soccer or no? No, it's trader. Okay, here's the first 3. Yoink. And then I got to double check that these coincide. So it does say a degree. B, it doesn't, I don't have leading coefficient down, but the leading coefficient is just 1, right? So this is letter A. This is letter C, the end behavior limits. So that is listed. People really love right no's, right? Someone's like complaining last hour. I hate writing these. Limit of f of x as x goes to negative infinity is negative infinity. As x goes to positive, positive. Number of zeros. This is a little misleading because there's a difference between zeros and x-intercepts. So be careful. I wish it said number of x-intercepts. There are definitely 3. There's also 3 zeros. Those are not mutually exclusive. Those are sometimes 2 different things. And we'll cover that when I see it. I'll show you what I mean about that. And then the points of inflection, just somewhere around here. You could possibly guess, though it is like right around there, but what is that x value? So there's nothing marked there. And don't go into trying to find the zeros of this polynomial. That's not what we're doing yet. So that's all we can do. But what is a point of inflection? When it changes from a bowl facing down to a bowl facing up. So that's a really good estimate of where that point of inflection is. And then this could be, you could possibly say that point of inflection is at 0, 0. That's a good guess. And then same thing with this one. Now notice this one, this is a degree 5, but it kind of looks like an upside down degree 3. And by the way, the leading coefficient of the second 2 are -1. So you gotta mark that in point B. But an x to the 5th sometimes doesn't show, like an x to the 5th usually would have one more wave in it. It'd have 5 directions to it. Increasing, decreasing, increasing, decreasing, increasing, or vice versa. It could, and hopefully I said 5 directions there. I don't know if I said 4 only, but not always. So we'll talk about that later as we see some others. Any questions on these though? All good? Okay, do the next 3, and then we'll get to talk about things that you're gonna have to remember about the next 3. Maybe not yet. It's really 7, 8, 9. 6 afraid of 7. 7, 8, 9. 7, 8, 9, that really gets some special things going on there. Okay, so then this is the next 3. We'll wait for 7, 8, 9 for that. I'm gonna get a drink of water. Again, my B is missing. Just say what the leading coefficients are. Don't worry about how do I know where those x-intercepts are. That was synthetic division last year, but there's actually more to it. We'll show you when we get. Sometimes we use our graphing calculator to get one of the zeros, and then that stuff's coming up. You can see 8 and 9 on the video. That's where we're getting sketching. And then 10, 11, 12 is real sketching. So knowing graph behaviors, knowing what to expect. Oh, remember math team thing? I think I did mention it to you guys. I forgot to mention it. 4th hour until today. So math team meeting is today, and then I'm ripping that down. I should have ripped it down now. I think anyone 7 hours ago. That could be a lie though. I know someone in AB was part of the team. Yeesh.
The math team, do I have to show
I'm sure we could just tell someone or email. You know who the coach is for juniors? I don't English. They would know who the juniors are? Junior? Who? Is it Weacher? I just call it Weacher. I don't know if it's very well. How'd she get married though? You did mention that. Okay, we'll walk around just so you're filling in those on your own. Yeah. It's kind of an easy day. Did I tell you tomorrow quiz is factoring? Did I say that? Okay. Fast factors. Yes. Sorry. Yeah, I said combination. No. Room right. R-O-M-M, really fast factors. Wrong. Oh, beautiful. Stay outside. Oh, I'm so tired though. I'm not going to do anything when I go home. Okay. Ready? All right. So going back to the key, yoink, and then sliding up here. All right. Let me just go in there. Cool. Okay. So remember A, then this is C, D, E, and then points of inflection. I'll just go over here and mark those right now with my fancy new pen. Okay, that's right around there. It's kind of tight. There's a couple points of inflection, maybe around here and around there, maybe on that one, and then there's none on the third one. That's what I was trying to get at here. Let's look at the third one as you see and then okay, so let's do B now. Leading coefficients 1, leading coefficients 1, leading coefficients -1. That's why it's down and down. Okay, I don't know if you can hear me when I speak away from this. One bad thing about this microphone. Okay, but going back to this, what was I going to say? Oh, look, I have an x to the fifth, but I literally only have one x-intercept. There are actually, you probably are going to get 5 zeros out of that, but 4 of them are probably what? Starts with an I. Anyone remember? Imaginary, okay? And that's usually the case. So technically there's 5 zeros. So this should say number of x-intercepts, because those are two different things. All right, and we did get imaginary zeros last year. We would have a cubic, we'd find 1 0, synthetically divide, and then have an x squared left over. Remember a depressed polynomial? That's what we called it. You know why? Because it was knocked down a degree. Like Mr. Samuels has been knocked down many degrees in his life. Anyway, and then you would use the quadratic formula, right? The opposite of b plus or minus blah, blah, blah. And then you get an I number there. So, all right. And then that last one, again, you have an x to the fourth, but you only have 2 zeros, 2 real zeros. I guess it should say number of real zeros, right? And then that might clean it up a little bit. And then I denoted the points of inflection and the missing b leading coefficient thing. All right, everyone good? Okay, notice 5 has 2 points of inflection. That's because there's 3 bowls. One facing up, one facing down, and then another one facing up. So I have 2 points of inflection. All right, do the next 3. Good. Yeah, those are the 8 and 9. You're really going to remember. This is when we went a little beyond the cubic. Already did the polynomial dance, right? Just want to make sure. Very important. Okay, and some of you are ahead already. Really mad that the eraser doesn't work on this, though. Do some testing here. Should be that. Nope. Should be that. Nope. Wonder if I could set up the pen. Oh well. Can't complain. Pen's way better. Oh, sure.
My bad.
My dog. Done? Done with all 15? You take a little break? Oh, water break. Sahara Desert. Gonna pass out if he doesn't get a drink of water. The math's killing him. Crinkle, crinkle. Water bottle. Okay, so I guess this is semi-new, but not really. We did end the year with cubics, and then things like 8 and 9 we definitely ended the year with. So I'll remind you of that here shortly. I should have timed it. You guys ready? 8, 9, 7? 6 afraid of 7, 7, 8, 9. Okay. Oh, sorry. I actually went to the wrong one. So 7, 8, 9, this is what I should have been showing these. Okay. Key. If you're watching the video, then just pause it if you wanted to see this live. Okay. Boom. Shaka lockers. And then hopefully we have the same thing. I think we have the same polynomials. Here are some things to remember. And actually, I'll use my pen. This is the first time in forever that I know that this is 1. I know that this is 3. And I know that this one's at -4 because this is in intercept form. I could plug in -4 and that would become 0 as an output. That means -4 comma 0 is an x-intercept. So these I could actually find. This would require some heavy math. If you're looking at the calculator, finding zeros that way, it'd be kind of hard by hand. In synthetic division, you'd have to kind of guess what those zeros are. Remember the P over Q list? Huh? You guys remember that? So the constant is 3, and the leading coefficient's -1. There's your answer for B. So the only possible rational zeros comes from this P over Q list, the factors of 3 over the factors of 1, both plus and minus. So the only possible rational zeros would be 1, -1, or 3, or -3. Possible, not actually. And then you'd have to synthetically divide and check those. You remember that? Okay, yeah. So that's what we made you do. But that's an x to the 6th. So it's hard to get that down to an x to the 2nd and then do the quadratic formula. So you need a lot more than that. Notice, a couple other things to notice. Think about this when you're doing your homework. This only has 3 extrema, and it's an x to the 6th. There should be 6 directions, 5, not should, there could. But the point is, this kind of looks like an x to the 4th right now. So not all the extrema actually show up in polynomials all the time. So minimum, that's an x to the 4th, because I see 4 directions, increasing, decreasing, increasing, decreasing. But it could be more. It could be an x to the 6th, an x to the 8th, an x to the 10th, if I did not see an equation tied to it. This is something to keep a note of. And then wait till you see number 12. I'll talk about that even further. You can see number 12, if you look at it, it's an x to the 4th as an equation. But then look at the picture. There's a little bit less going on there. All right, and then this one has a couple of points of inflection. So possibly here and maybe right around there, because I have 3 bowls. I have a bowl down, a bowl up, and then a bowl down area. So those are really tight and close together. Number 8 only has 1. It is a cubic, and you got to think about it as a cubic if I foiled it out. And then same thing with this one. Oh, and then this is another one. Oh, sorry. Yes, I know this is at 1, 0. And I know that's a bouncer. This is what we did last year. You were expected to make sketches of this through zero analysis. And then I know this is at -4. So it's a little skewed. That 1 should be tighter, closer to the origin, but whatever. You get the idea of this. So those are things you actually are supposed to know. That's from last year. Okay? Everyone else good on all the other stuff? Leading coefficient -1. If I foiled this out, it'd be 1. If I foiled this out, it'd be 1. Actually, we talked about that from our first one. Okay? All right, do the next 6. Hopefully you go fast on those. And then we'll call it. Boring video. I can't pause. It's a wee video. It drives me nuts. You got that? Done. Yeah, done. No. Hold on. You got that? You know, so you're done. Oh, I gotta get going on your test too. Hey, make a key so far behind. Yes, he's going to me. Wednesdays are the worst. Worst. Do you run like Wednesdays? Complain about it? Never heard a complaint. No, it's great for you guys. Terrible for me. It's perfect for you guys. Probably shouldn't be speaking about this, getting this on tape. How much I despise Wednesdays. This takes my brain and goes and just scrambles it like scrambled eggs. And I have to teach. Oh, sorry. No one's playing at home anyway. Well, yeah, look at these. Now we're talking. Okay, I think most people fumble over there. All right. Okay. So maybe market, man. So, and again, this is I don't know what that is. Oops. Okay. All right. This is at 1, and then this is at -3 because I could look at those zeros. So it's a little skewed, a little off as far as scaling, but who cares? And those are double zeros, so those are bouncers. All right. Those are tangent to the x-axis. Did I mention that on the previous one? Did I have a tangent? I did. Number 9. Okay, so things to remember. And then check this out. This is 1, and then this is -3. Again, scaling a little bit off, distances, but that's exactly what's happening. And you had to do that last year. You had to make a sketch and show what a cubic zero looks like, which it looks like a cubic function. The parent cubic function has that point of inflection right there. Well, a cubic zero, if you just look at that little local spot there, that's what it looks like, a cubic. That's why. So I have 2 zeros, but this one counts for like 3 of them. Like all the zeros should account for the degree of the polynomial. So degree 4, there should be 4 zeros accounted for. 3 of them are in that multiplicity, right? And that's what we called that, multiplicity 3. This is a degree 4, and the 4 zeros are accounted for. 2 zeros have multiplicity 2. The multiplicities add up to 4. And then the last one, for sure, this is at 0, 0. Are we okay over there? All right, and then this is a double zero there at 4. So you might want to mark those things. All right, so that's stuff you're supposed to remember. Okay, and I think all the rest is good. You good on that? And then I can show the last one. Good. Any questions? All right. So ideas that we're supposed to know, and then this is what I mean about zeros. And then, but I have an x to the 4th. Shouldn't I have 4 zeros? But I only have this 1. It's because it's a bouncer. So this is a multiplicity 2. Kind of tough to say what the other 2 zeros are. Actually, I think if I remember from the past, they are imaginary. Believe it or not, it's crazy that there's 2 other zeros that raised to the 4th power do solve that equation. And same thing with that 5th. But look at that. It looks like it's a cubic. So any odd multiplicity higher than 1, 3, 5, 7, 9 would go through like kind of like a cubic, right? Just a little bit flatter. All right, and then we got our classic double. I think this one changed, right? Doesn't yours say +1, right? But isn't your graph over here? Yeah, so just leave yours. It's fine. They changed it on this key for the this teacher version, but you have 1 and you have -1 and -2 as your zeros, and you're fine. All this other stuff stays the same. Okay, good to go. Remember all that stuff. All right. So good enough. Video longer than it needed to be because I wanted students to do some stuff there. I don't know what I just said there, but